Hello everybody, today inshallah we're going to complete the forces. We'll start by measuring the force. How to measure the force? It's with a scale called spring scale, or we can call it spring meter, and the unit of measuring forces is Newton. From where do we get this concept or name of Newton? For sure it's called after the great scientist Sir Isaac Newton. Before we go to him, let's compare between weight and mass. Mass is the amount of matter inside the object, and matter, we know that matter is solid, liquid, or gas, and when we go deep it will be composed of atoms. So mass is related to the atoms themselves. Okay, so the mass will never change. The mass of an object will never change, but the weight may change. Why? Because weight is affected by gravity. Weight is the mass multiplied by gravity. Weight is the gravity, the force of gravity pulling the object down. Okay, so if the gravity changed, so for sure the weight will change. Let's go to the gravity. Gravity is first discovered by Sir Isaac Newton when he was, this story about of the falling apple. He wondered why the apple fell down, not to the left or the right, or go upwards, and then after thinking too much, he made the concept or the theory of gravity. And the gravity from this time was always represented by an arrow going downwards, and for sure from this you'll know that the weight is affected by gravity, not the mass. Okay, gravity is an invisible force. Okay, we can't see it, but it's pulling everything towards the center of an object, and here we're talking about the earth. So gravity of the earth is the force that's pulling everything toward the center of the earth. Okay, but not only the earth have gravity, but also everything is having gravity. Okay, pulling everything toward the center. So the gravity of the sun, it will be a force pulling everything toward the center of the sun. The gravity of Jupiter will be force pulling everything toward the center of Jupiter. And since the planets here are smaller than the sun, so they are rotating around the sun because of the gravity. Okay, gravity of the sun is attracting all of them. That's why they are rotating. So from this we can know that the bigger the object, for sure the bigger the gravity. And from this, the earth is having a greater gravity than the moon. So if we made an experiment to see what will happen to an object that will be placed once on the earth and once on the moon, for example an astronaut is measured here on earth and measured on moon. If he has or he weighed 120 on earth, for sure he will have a less weight on moon, and it will be exactly 20 kilograms, and this is because the moon is having 1/6 gravity of the earth. Okay, and for sure this is not weight 120 kilograms. This is not accurate, and you are just saying this as common people, but scientifically the weight is with Newton while the mass is with kilograms. You'll find for sure that the Jupiter, since it's much bigger than the earth, so it will have also greater gravity. So your weight on Jupiter will be more than your weight on earth. Can you guess what will happen if we have two objects having the same size, the same shape, but one of them is having a greater mass, and we need to let them fall from a certain height? Which will go down the first? By sense you may say that the heavier will go first, but actually a great scientist called Galileo made an experiment and made this. Really, he climbed the top of the tower Pisa, and he let two balls having same shape and same size to fall down, but they have different masses, and the result that both of them reached the ground at the same time. And this was really something that need further investigation. That's why they tried to think that this means that everything will be pulled by the gravity of the earth with the same speed. So anything, I don't care about its shape, its mass, if we let them fall from a certain height, anything will fall with the same speed and hit the ground with the same speed. And even if I let a hammer and feather to fall with from a certain height, they will reach the ground with the same speed. And logically we can't believe this, or if we need to think about this, but they made this experiment on the moon. Okay, they let a hammer and a feather to fall from a certain height. Can you guess what happened? They reached the ground of the moon with at the same time. But why this may not happen on Earth? This is not because of the gravity, but because of something on Earth called air resistance. Okay, if it's only about gravity and there is no air, if we make this experiment on Earth, the same result will happen. The hammer and the feather will reach the ground with at the same time, but this will never happen on Earth because of the resistance of the air, because the feather will be affected by the particles of the air, and it has a great surface area, so it will stay on falling for a longer time. Okay, we finished gravity now, and we need to go to another force called friction. Friction actually is a push against a moving object. And if we need, this guy is moving in this direction, so friction will be here. Okay, it will be directly opposite to this direction, and it will be according to the two surfaces, the wheel surface and the ground surface. Okay, as you see here, friction can be represented by this arrow. Friction is also always related to the surface. Okay, and it's like a force that will make everything slow down or stop. Friction with a rougher surface will be more. Okay, the rougher the surface, the stronger the friction. And for sure also, if we have a greater surface area, it will make more friction than something with a small surface area. Friction may cause heat. If you try now to rub your hands, what will happen? You will feel heat. So sometimes we need to reduce the friction, like here in these gears. If we put oil on them, what will happen? They will move easier. This means that the friction will decrease because we don't need heat here. Okay, also in the car we put oil on the car motor to decrease friction, so as the heat will decrease from the movement of the metals inside the car motor. Here these ice skaters, we make when we need to decrease the friction, we decrease the surface area that is contacting the ground. Okay, but friction is really useful. Sometimes we need to decrease the friction, but really without the friction our life will be a mess. How can we stop a bicycle without friction? Okay, also how can you walk around without friction if your shoes is not making a friction with the ground. And if there is no friction, you'll be sliding all the time. You can't move, you can't stop yourself. Also, you can't hold anything with your hand if there is no friction, because it will slide from your hand like there is oil. Okay, so really we need friction, and it's very useful. And there is two other forces that are related to friction, which are air resistance and water resistance. It's air resistance force that acts on any object that's moving through the air. Water resistance, or the same force acting on any object moving through the water. Okay, it's like how the air particles or the water particles are hitting you when you are moving through them. Okay, for sure in the air resistance it's all about the particles hitting you. And if you can see here in this picture, this parachute is moving down. We have two forces, gravity pulling down, and air resistance on the opposite, because the particles of the air will be hitting in this direction. Okay, for this girl, she is moving. There is also air resistance against her and driving force on the opposite direction. So we can find that the air resistance sometimes is useful and sometimes it's unuseful. In the parachute, for sure in the parachute it's useful, right? Because we need to slow down while landing with the parachute. But here if you are moving your bicycle or your car, you'll find that the air resistance is like slowing you down, and you don't need to slow down from the air resistance type. And for sure you'll find that the perfect parachute will be that the parachute was having a greater surface area, because it will have greater contact with the air particles, so it will let you slow down as much as possible. Okay, air resistance will be always according to the movement. And this parachute, the air resistance will be like that. Okay, for the bicycle, the car or the bicycle, if the car is moving like that, the air resistance will be this direction. So we are just looking for the air particles, how they will oppose your movement. Okay, guess the forces here. What will be this force and this force? Yes, this is the movement force by the bicycle, but this is the friction between the ground and the car tires, and this is the friction, not the air resistance. The air resistance is here. The air resistance is here. Okay, against the body of the girl or the body of the bicycle. Okay, the water resistance is the same, but inside the water. Okay, you'll be swimming in this direction, and the water resistance will be by the water particles, like trying to stop you or slowing you down. In these pictures you can see many cars, but these cars look different than these cars. These cars, they are clear that they are race cars. Why there is a difference between normal cars and racing cars? The difference is that the racing car, we need to decrease the air resistance as much as possible to make it faster as much as possible, like here. Okay, you'll find if this car is moving, the air will be hitting it. So if the car is streamlined shaped, what will happen? If the car is streamlined shaped, it will be faster, because it will be like moving through the air easier. The surface with contact with air will be smaller. Like here, which truck will move faster? For sure this truck. Why? Because the air will move like that easily, right? But this truck, the air resistance will be like that, and will be stopping the car and or slowing it down, and this means that it will increase the fuel consumption and make it slower and everything. Okay, so streamlined shaped is solving the problem of air resistance and also solving the problem of water resistance. And this train you'll find it streamlined shaped, so it will move fast. This aeroplane streamlined shaped, it will also move fast. You will find that the nose here is pointed, the back is smooth and curved, so the air will not will be opposing the whole surface. Okay, so it can move faster. Also, Allah created the fish, as you see here, with a streamlined shape, so they can swim easily and decrease the water resistance. Thank you.